Hi, we have AP Physics 1 Past Paper 2024. We are discussing free response question section. In this part, question number 2 carry the 12 points. A student hang the spring of unknown spring constant K vertically by attaching one end to the stand as shown in the fig. The other end spring has a small loop for which small cylinder can be hung. In addition to the spring, student has access only variety of cylinder of unknown masses, a stopwatch, and the digital scale. Design an experiment produce the student could use to determine the spring constant of the spring. In following table, list the quantities that would be measured using only the provided equipment in your experiment. Define a symbol to represent each quantity. In a space below the table, describe overall procedure, provide enough details so that another student could replicate the experiment, indicating any step necessary to reduce experimental uncertainty. As needed, use the symbol define the table. If needed, you may include simple diagram of setup with your procedure. Okay. Now, the quantity to be measured, we have to measure the time period of oscillation. Its symbol is T. That's why we use the stopwatch. And there are different masses of unknown, different cylinder of unknown masses. So we have to measure the mass of cylinder. So that's why we use the digital scale. The symbol of the quantity is M. Now the procedure is we use the digital scale to find the mass of one cylinder or combination of them. Hang the cylinder from the loop of the bottom of spring, ensure spring hang vertically, allow it to come to rest. Gently pull the cylinder downward and small distance and release it set into vertical oscillation. Using the stopwatch, we measure the time for the 10 oscillation for the mass to complete 10 full oscillation. T10 we representing the time for the 10 oscillation. Repeat this at least 3 times for the same cylinder to obtain the average value of the T10. Now, time period can be calculated by divided by this time by 10. So this is the time period for the one oscillation or time for required for one oscillation. We can use the spring constant y 4 pi square mo by t square. M is known from the spring constant. Time period is known from this tool. So we can use this formula to calculate the spring constant. Now, repeat for different cylinder of different masses with the large number of oscillation to reduce the experimental uncertainty. Okay. Indicate the quantities that could plotted to produce the linear graph whose slope can be used to determine the spring constant. Vertical axis, what should be at horizontal axis. Now, vertical axis should be t square, horizontal should be m for mass. We have the formula T is equal to 2 pi square root m by k. As we know that y is equal to mxk, m is slope of the line, so y vertical axis and horizontal axis. If we square this formula, t square is equal to 4 pi square by k into m. This is the vertical axis, y axis. This is the horizontal axis. This is the slope. So as from this formula, we can indicate the slope is 4 pi square by k. Okay. Describe briefly how slope of the graph would be analyzed to determine the spring constant of the spring. The graph of the t square versus m should be straight line through the origin with the slope 4 pi square by k as we have highlighted in a previous. Therefore, after determining the slope of graph, calculating the spring constant as we move the k across and slope is from downward. So that's the value of the from using the graph of slope and divide 4 pi square divided by slope give the answer of spring constant. Now, in different experiment, the student attach one end of the spring to the force sensor and that is attached to the wall. The other end of the spring is attached with the mass 0.25 kg. Student place the motion detector to the right of the card as shown in a fig 2. Then pulls the card to the right a small distance so that spring is stretched. Student release the card from rest and card spring system oscillate. Following graph show the velocity of the card and the force exerted on a card by the spring function as the time. So that's the velocity variation of the spring mass spring system, and that's the force exerted on a system. Now the question is, use the data in the velocity time graph, calculate the change in kinetic energy of the card as time interval t05 to t2.0 second. Now velocity time graph, we can calculate t, this is the time when we measure the velocity, that's a zero point 0.3 meter per second. And the what is the 2? When we are 2, we are at this point, there is no velocity, velocity is at 0. So we have the initial velocity point plus 3 0 0.3 meter per second, and the final velocity we can calculate at 2.0. So change in kinetic energy final minus initial. So we place the value, we have the value of mass, so answer is minus 0.01125 joule. So that's the indicating that the change, there is decrease in kinetic energy, increase in potential energy if we calculate the SHM. Now, using the data of force time graph, estimate the change in momentum of the car from zero point 0.5 to 2.5 second. Briefly explain how you arrived your estimation. There is change in momentum equal to the impulse, which is area under the force time graph. From zero point 0.5 to 2.5, area above the time axis give positive force, contribute positive impulse. Area below the negative force contribute the negative impulse. Positive and negative areas are equal and symmetric as you are seeing in this red and green. Therefore, net area is equal to 0. The total impulse is approximately 0. So, change in momentum is equal to 0. And you can alternately discuss force time graph. We have the time zero point 0.5 force is 0 at this instant, and the 2.5 force is also 0 at this instant. We know that delta F is equal to rate of change of momentum. From change in momentum we can calculate F into delta T. Change in momentum is change in force is equal to 0, so change in momentum is equal to 0. So we can calculate predict this from this formula also. Okay, do the data from the velocity time graph confirm your estimation from the part C? To briefly, from velocity time graph, we have the point time 0.5, velocity is plus 0.3, and after 2, there is a plus 0.3 meter per second. So the change in final minus initial velocity is the same. Sorry, that's the 2.5, not 2. That's the 2.5. Time is 0.2.5. Now the velocity is same at both instants. So the mass is already same, velocity is already same. So there is no change. So we can say that there is change in momentum is equal to 0. The velocity is same at start or end interval. Change in momentum must be 0, confirming the area based estimation from the force graph. So that's the answer. If you have any query, kindly ask in a comment.